getting the ellipse right is one of the most challenging things in sketching in perspective, and so we're going to talk about the ellipse a little bit right now. And if we think about a circle, and we think about one inscribed inside of a square. We've got some midpoints on that square out here, and if I sketch this correctly and took a little bit more time, what happens if we blow up that midpoint? So this is going to be my midpoint right here, so we're basically blowing this up. And this circle comes through that midpoint. And when it does and hits that midpoint, that line is tangent to that circle right at that midpoint. And the same thing is going to be true when we look at a circle in perspective, but that's kind of rule number one. And if we take a point inside here and then we draw we draw lines where if I draw this up and where it intersects the circle, I should be able to draw over here, draw down. Then I've got a square inscribed inside of a circle. And that's a way to check it. And there's one last thing I want us to look at on this simple circle, and it is this shape right here and that opposite shape over here. And notice that it's everywhere along the circle. If I rotate this 90 degrees, the same thing happens there. So what about a circle in perspective? I'm going to draw a simple face in perspective. So this would be maybe the side of a cube. These lines are converging. These lines are parallel. We're doing two-point perspective. And what I'm going to do here is I'm going to find the center of the surface. And the way that I can do that is I can put a simple little X in there. That gives me the center point. Then I can draw some lines in here. These are moving towards the same vanishing point. They're converging. And it gives me the midpoints, which we're going to relate back up to this flat square. Gives me those midpoints. So when I sketch in an ellipse on this surface, I want to make sure that they're coming through these points tangent. The other thing that I need to know is I need to know the minor axis. And the way to think about a minor axis is it could be the axle for a wheel. So if that circle was a wheel, whatever you're drawing in perspective, then you want that to be the axis. If we were looking at this flat one, then that axis is going straight through there. So on this one, these three lines are moving towards the left vanishing point. They're moving towards the right vanishing point. And we want a line that will be our minor axis that is moving towards the right vanishing point. The left vanishing point. And this is our minor axis. In fact, I'm going to come in just to emphasize this because it's so important and put a red line there. And what we've talked about already with ellipses is that we want an ellipse to be bisected by this minor axis. And so what this has done is it's given me an angle to look at that ellipse. So again, if we go back to some of the earlier exercises, I had you just draw some circles, some lines, and then draw ellipses. No matter what that angle is, that ellipse, its angle is defined by this minor axis. And so I'm going to do the same thing right here. And as I'm doing it, I'm ghosting it in, and I'm also thinking about how that's going to come through these points, tangent. So this, if we move it down, basically you're going to see something very similar. If this was my midpoint, then this curve, and on this one it's going to accelerate as it comes around. So it's going to come through that point, tangent, just like this. It's going to do the same thing at each of these other points. So now I'm just going to darken that in. I've got a pretty good idea of where that ellipse needs to be. I can check it. If we look at this, I can check it. One means to check it is to draw in this line right here, really in any direction, and see if this visually looks correct. As I darken this in, I'm going to talk a little bit about how this ellipse works and how ellipses work. And basically, if you look at the minor and major axis of an ellipse, it defines the angle, but why does an ellipse have an angle? And it's because the curve is constantly either accelerating or decelerating. And between here and here, it's decelerating, it comes through this, it starts to accelerate. Think about it as momentum. It's going to carry it around that curve. It's going to come back in here, it's decelerating, and it's going to start to accelerate about right here, and then work on around. But you can almost think of being in a car and trying to pull a tight curve. The momentum's going to carry you through this. So even though you're decelerating going into that curve, you've still got momentum that's going to carry you around. With an ellipse that is on a vertical or flat surface, the minor axis is not defined by either of the vanishing points. This is to the right vanishing point. It's defined by just a vertical line. So if you've got an ellipse that's sitting on a top-facing surface, then the minor axis is going to be straight up and down. And it's bisected, so you see that again. If we were going to draw the square that this ellipse is inscribed within, we'll check and see if our rules are still true. And they should be. If these are the midpoints of that square, then this ellipse should be coming through tangent. And you'll notice this is pretty tight. And the only way to do that is there's a lot more momentum that carries this ellipse through that curve and on around than on a little bit fatter ellipse. But this should be bisected by the minor axis. It's sitting on a top surface, so if we draw things like, let's just say, a glass, drinking glass, it's got two ellipses. It can sit just like so. And that should be bisected. The minor axis is just running through again, just like it's the axle of a wheel. This is like the axle of a wheel.